MCP just shipped its biggest revision since launch, and buried inside it is something way more interesting than stateless is now the default. A real fix for a real attack class plus a completely new enterprise auth layer. We've covered MCP's architecture rebuild already on this channel, and tools versus resources, and why MCP exists in the first place. Today we're going somewhere we haven't been: security and authorization. Specifically, the mix-up attack that MCP's single client many server pattern makes unusually easy to fall into, the RFC-backed fix the spec just mandated, and enterprise-managed authorization. The new extension that Anthropic, Microsoft, and Okta have already shipped support for. This is protocol level stuff. Headers, tokens, actual attack sequences. If you're building or deploying MCP servers at any real scale, this is the video you don't want to skip. Let's get into it. So what was actually wrong with MCP auth? Three things really. First, consent fatigue. Standard OAuth in MCP is user scoped per server. Connect to 5 tools, approve 5 separate flows. That's annoying for one person, and it's a nightmare for a security team trying to onboard a whole company. Second, and this is the one nobody was talking about, mix-up attacks. Because MCP is a single client talking to potentially dozens of different authorization servers, there's a real risk the client gets confused about which server actually issued a response. That confusion is exploitable. Third, no central control. Individual employees approving individual servers means security teams have no single place to enforce policy. The July 28th SPIC update tackles this from two angles at once. It hardens the core protocol against the mix-up attack specifically, and it ships a whole new extension, Enterprise-Managed Authorization, to fix the consent fatigue and central control problem. We're covering both. Let's walk through the attack step by step because it's simpler than it sounds. MCP's whole model is one client, say your IDE or Claude, talking to many different authorization servers, one per tool or server you connect. Step 1. The client kicks off an auth flow, but through some redirection or misconfiguration, it ends up talking to an attacker-controlled authorization server instead of the legitimate one. Step 2. And this is the core of the vulnerability, that attacker server hands back an authorization code. Before this spec update, there was no standard mandatory way for the client to check which server actually issued that code. Step 3. The client, still believing it's mid-flow with the real server, forwards that code onward, and the attacker can now use knowledge of that exchange to impersonate the client against the real MCP server. This is called a mix-up attack, and the spec authors specifically call out that MCP's single client, many server pattern makes it more prevalent than in typical OAuth deployments. Next, the fix. The fix the spec mandates is almost embarrassingly simple, which is exactly why it's a good fix. Low cost, high value. As per SEP 2468, clients must now validate the ISS parameter on the authorization response following RFC 9207. In plain terms, the authorization server has to say who it is in the response, and the client has to check that against who it expected to be talking to. Let's walk through the diagram. Same setup, client talking to an attacker server. But now, when that response comes back missing the ISS parameter or with the wrong one, the client rejects it outright. The mix-up attack just doesn't work anymore. One important detail. Right now, this is a should. Authorization servers should supply ISS. But the spec explicitly says that in a future version, clients will be expected to reject any response that omits ISS entirely. So if you're running an authorization server for an MCP integration, the message is clear. Start supplying ISS now before it becomes mandatory. That's the headline security fix. But it's not the only one. The ISS check gets the headline, but the spec actually hardens authorization with 6 SEPs total working together. Here are the other 5 quickly. SEP 837 has clients declare their OpenID Connect application type during registration, so a desktop or CLI tool doesn't get defaulted to web and have its localhost redirect rejected. That's a real paper cut a lot of developers have hit. SEP 2352 binds registered credentials to the specific authorization server that issued them and forces re-registration if a resource ever migrates to a new one, closing another door attackers could otherwise use. SEP 2207 documents formally how to request refresh tokens from OpenID Connect style servers, removing ambiguity that different implementations were handling inconsistently. SEP 2350 clarifies how scopes accumulate during step-up authorization. Think this action needs more permission than we started with. And SEP 2351 nails down the .well-known discovery suffix so clients can reliably find an authorization server's metadata. None of these make headlines on their own. Together, they're the difference between a protocol that's theoretically secure and one that's secure in the messy reality of real OAuth deployments. This is the other big piece of the release, Enterprise-Managed Authorization, or EMA, and it just went stable, adopted already by Anthropic, Microsoft, and Okta. Here's the flow. The user signs in once through their organization's identity provider, Okta, in the first shipped integration. That's step one, and it's the only interactive login the user ever sees. Step two, instead of the client running a separate OAuth dance with every single MCP server, it requests something called an ID-JAG, an identity assertion JWT authorization grant from the identity provider, scope to the server it wants to reach. Step 3. The MCP server's own authorization server validates that assertion against the identity provider and, critically, issues an access token without ever showing the user another consent screen. Step 4. The client connects to the actual MCP server using that token. Multiply that across every approved server in the organization, and you get what the MCP team calls a zero-touch flow. Sign in once, and you have access to everything your organization has already approved. No more onboarding friction, no more 20 individual consent prompts. This isn't a paper spec, it's already shipping. On the identity side, Anthropic, Microsoft, and Okta are named as the first adopters, with Okta's cross-app access as the first fully supported path. On the client side, Anthropic has rolled out support across Claude, Claude Code, and Cowork, and Visual Studio Code has added it in the IDE too. And on the server side, real production tools already support it. Asana, Atlassian, Canva, Figma, Granola, Linear, and Supabase, with Slack listed as in progress. That breadth matters. This isn't one vendor's pet feature. It's shaping up to be the default enterprise auth pattern for MCP, not a special case you bolt on. If your org is already using any of these tools with Claude or VS Code, there's a real chance this applies to you sooner than you'd expect. Now, the part almost every summary of this glosses over, and it's the part that actually matters if you're the one deploying this. EMA is connection level. It answers exactly one question. Can this client reach this server, and with what scope? That's it. It is explicitly not runtime authorization for individual actions. Once that token is issued, EMA is not watching what the agent actually does inside the server. It doesn't inspect the MCP traffic that follows. The MCP team's own guidance is blunt about this. Organizations still need their own controls for what happens once an agent is inside a system. Centralizing who gets in the door does not replace the need to govern what happens once they're through it. So, if you're evaluating EMA for your org, don't mistake "we solved Ayuth" for "we solved agent governance." It solves a real, painful problem, but it's one layer, not the whole stack. So here's where this leaves you practically. The release candidate has been locked since May 21st, and the final spec ships July 28th. That's your window to validate against real workloads before it's final. Two concrete actions, depending on which side of this you're on. If you run an MCP authorization server, start returning the ISS parameter now, even though it's technically optional today. It becomes mandatory in a future version, and clients will start rejecting responses without it. If you're evaluating MCP at an enterprise level, look at enterprise-managed authorization before your per-server consent prompts become a scaling problem. Just remember what we covered. It's connection level, not a replacement for your own runtime governance. That's the Auth overhaul, a real fix for a real attack, and a genuinely new enterprise Auth layer, both landing in the same release. If this was useful, let me know in the comments whether you want a follow-up on MCP apps and tasks, the other two big pieces of this same release. Thanks for watching this session, and I'll catch you in the next one.